I am going to explain vectors. What are vectors? Vectors, unlike scalars, have direction. Scalars only have magnitude and vectors magnitude and direction. They can be in 2 dimensions or 3 dimensions expressed by x, y, or x, y, and z. They have components and an angle. The angle gives us the direction, and the components are in x and y. These are the formulas for the components in x and y, and this is the formula for the magnitude of the vector in case you only have the components, and this is a formula for getting the angle.
Coulomb's law refers to the force between two electrically charged particles that are separated by a distance. To calculate this force, you can use the formula F equals K times the absolute value of Q1 times Q2 over R squared, where R squared is the distance raised to the second power. Q1 and Q2 are the charges, and K is Coulomb's constant, that is equal to 1 over 4 pi epsilon 0, which has an approximate value of 9 times 10 to the 9th power. It is also important that you take into account that the charges should be in coulombs and are in meters. And also, you need to take into account the principles of attraction and repulsion, which state that alike charges will repel each other, while different charges will attract each other.
What needs to be done first in this problem is to analyze the distance between each point. It is easier if you locate the origin at the middle charge because all distances are equal at this point. So once you have calculated the distance with Pythagoras, what needs to be done next is to calculate the force with Coulomb's law. In order to know the magnitude of the vector of the force that is exerting in each charge in this point, it needs to be analyzed separately. But in order to make a complete analysis, you need to decompose in components the vectors.
Apart from once you have done that analysis, what you need to do is calculate the direction of every vector with the vector cosine. And also you have to make an analysis of the charge, if it is positive or negative, so that you get to know if the signs of the coordinates are changed. Once you have calculated each angle, you need to find the magnitude by multiplying the force times the cosine of the angle. And in that way, you get a force for every component in x, y, or z, and you have to add I, j, or k, depending if it's x, y, or z.
Once you have summed this, you will get a result, and this result will be 3 unitary vectors. That is actually one vector expressed in 3 different coordinates in a 3D plane. This is why the final result is actually the total force that are all these charges exerting at this charge. So the final result means that it is a vector of all the forces that are exerted at this point.